Okay, boys and girls, we are on day 2 of the Trebuchet Gizmo, starting with number 6, activity A. And the learning target is identifying how moving the short arm length impacts initial speed. Basically, following along here, you start with making Trebuchet 1, set it up so that the settings all equal what it says here. So, for instance, counterweight 4,000, payload 200, just verify that. Counterweight 4,000. So you move your settings. You're still in the design mode, by the way. So 4,000. Your payload is 200, fulcrum 9. A little bit of back and forth here. Fulcrum 9, payload. What did I say the payload was again? Oh, this is tough to do. 200. Sorry about that. Too many tabs open too. 200. Fulcrum 9, short arm length, based on the graph or on the chart is 1.0. Long arm is 9, so make sure that's that. Short arm is 1.0, long arm is 9. Sling is 5 and prong angle is 40. Let's check that. Sling is 5. Nope, sling needs to be 9 and prong angle 40. So I think that's what it was actually. Sling length is 9. Okay. So you see how it takes a little bit of back and forth there. I was just modeling that also, just verifying that these settings are all equal. Then launch test. Okay. Long sling angle, sling length for sure. Okay, it doesn't look like it did anything. The launch angle was 128.56. The initial speed was 19.05. So back at your table, initial speed is 19.05, 19.05. And that's again meters per second, meters per second. Okay, and basically you do that. Now just adjust only the short arm length for 2, for 3, 4, 5, and 6. Then you basically set up Trebuchet 2, but your counterweight is 6,000. Your payload is 40 kilograms, fulcrum 9, long arm 9, sling 9, and prong angle 40. So a few slight changes there. Put in the initial speed for each of those. And then on the next question, you'll just be basically asked to analyze how did the two trebuchets differ. For trebuchet 1, which short arm length produced the greatest speed? Which one produced the greatest short arm produced the greatest? So for trebuchet 2, which short arm length produced the greatest initial speed? And then what short arm length maximizes the initial speed? So I'll set these up for you to be able to answer just fine. And then finally, how does the optimum means the best, like the optimum, the best short arm length. How does that change when the payload is light compared to the counterweight? So payload meaning whatever rock that they're throwing. If that's light and the counterweight's heavy, or the payload is heavy and the counterweight is light, what's the best combination of those is what they're asking in relationship to the short arm. So that one's a pretty tricky question. I might even make this one a bonus question here. And then we'll be moving on to activity B after that.